Sea microplastic pollution has been a serious problem that brings great disaster to the health of various species of organisms, especially marine organisms and humans. According to researchers, there are approximately 50 to 75 trillion pieces of plastic and microplastics currently in the ocean, and microplastic particles were found in 100% of the water samples and marine organisms. According to another study at Kuantan, Pahang, Malaysia, the abundance of microplastics found on the water surface is in the range of 0.14 to 0.15 particles per kilogram. We can't just stop the use of plastics for now, because it plays important roles in our life. But we must try to collect them back even if they are in very small pieces. And that's what defines the objectives of our project, which is to determine an efficient way to clean the sea from microplastics pollution and also to promote a way to reduce water pollution.
Our solution is designing a boat which separates microplastics from the ocean, and we name it the Microplastic Extractor. Instead of being stationary, it glides through the surface of the ocean to collect wastewater that's polluted by microplastics. After the wastewater is collected, electrocoagulation will be carried out to separate microplastics and waste solid particles from the wastewater. But how does the electrocoagulation process work? First, we prepare two aluminum electrodes. When the DC power supply is connected to the circuit, electrons will start flowing in the system. The anode will undergo oxidation and release metal ions. In this case, we are using aluminum, so it will be aluminum 3+ ions. Meanwhile, the cathode will undergo reduction and hydrolyze water particles into hydroxide and hydrogen ions. The aluminum 3+ ion will combine with hydroxide ions to form aluminum hydroxide coagulants. These coagulants will form a sludge blanket which trap the suspended solid particles. The hydrogen gas liberated in the hydrolysis process will then leave the resultant sludge to the water surface. Those coagulants on the water surface will then be separated from the wastewater. For your information, our team have applied this concept in our innovation. To increase efficiency, we added more electrodes as this will increase the total surface area to speed up the reaction. First, we will pump water into the water tank and let the electrocoagulation process to take place. Coagulants will float on water surface once the process is done. Then we'll continue to pump water into the water tank to make the water overflow, so that the coagulants can flow into the coagulant tank as they will follow the movement of the water. Hence, microplastics are separated from the water. And this process will be repeated again and again. We have planned an experiment to verify our theory.
In our experiment, the apparatus used are aluminum plates, beaker, DC power supply, hot plate, magnetic stirrer, crocodile clips, filter paper, filter panel, and wastewater. Firstly, we set up our apparatus as in the beaker. The wastewater is poured into the beaker. We then switch on the DC power supply and hot plate. After that, the magnetic stirrer of the hot plate is turned on to stir the wastewater. Wait for 10 minutes for electrolysis process to take place. 10 minutes later, we turn off both DC power supply and hot plate. The wastewater is left for 5 minutes to allow the impurities to float to the surface of the water. As a result, we could observe that there is a thin layer of pale brown solid is formed on the surface of the solution. This is because there are solid waste accumulated on the surface of the solution. We suspect that there are the presence of microplastic in the wastewater.
In contrast with the wastewater before, we can spot those solid particles with bare eyes. The experiment observation is the same as our hypothesis.
As for discussion and reference, one of the errors is that the aluminum plates may accidentally contact each other. Next, the coagulants may not be lifted continuously too. To prevent those errors from happening, precautions were taken. Magnetic stirrer is used to speed up the coagulation process. The aluminum plates are fixed in fixed position too. Moving on to the question regarding the experiment we conducted, which is what are the solid substances found on the water surface? We suspect those consist of microplastics that couldn't be spotted with our bare eyes before the coagulation process occurs. The references we used are as listed below, and that's all for our presentation. Let's clean and remove microplastics from the waters. Thank you.